everyone, this is Dr. K. Balamurugan, Faculty of Mechanical Engineering. In today's session, we are going to see the projection of points. Let's delve deep into this by looking at a sample test problem. So here's a problem given to you. Let me read a problem. A point P is 15 mm above the HP and 20 mm in front of the VP. The another point Q is 25 mm behind the VP and 40 mm below the HP. Draw the projection of point P and Q, keeping the distance between the projector equal to 90 mm. Draw a straight line joining the two top views and the front views. We will look up into the point. The point P is 15 mm above HP and 25 mm in front of VP. It's very clear that when the point lies above HP and in front of VP, that means the point lies in the first quadrant. Let us look over the second point Q. The Q is 25 mm behind VP and 40 mm above HP. So behind it and above are the two keywords, which clearly means that the point is lying on. So if I look up over the point P, is the first quadrant. 15 mm is denoted as H and 20 mm is denoted as D. And the two planes has been drawn, vertical plane and the horizontal plane. The vertical plane and the horizontal plane intersect at a point which we are marking as X and Y. And this is going to be the referral plane for both VP as well as HP. Now we will mark the point P somewhere in the first quadrant. So it's very clear that the point P is 15 mm above HP and it is 20 mm in front of VP. So we are marking the 15 mm above the horizontal plane and 20 mm in front of the vertical plane. So here the blue color is a vertical plane and rose color will become the horizontal plane. Always the observer will be looking from the right hand side of the viewer, and in the top view the observer always sees from the top. Irrespective of the quadrant, both the front view and the top view will be looking like this. So always the notation that falls on the vertical plane, that is the front view, will be marked with P dash, and with respect to the horizontal plane we are going to mark with P. Now I am just tracing the point P dash and P with reference to the reference plane. A line has been drawn. Since the point lies 15 mm above HP and 20 mm in front of VP, the line has been marked. Now we will look up into the point Q. If I look up into the point Q, the point Q is 25 mm behind the vertical plane and 40 mm below the HP. So behind and below. Behind and below, obviously it falls under the third quadrant. It's very clear. And a 40 mm below the HP line. See, so it's obviously it is going to be the third quadrant, and that's what I have been marked as the tip over here. So here the two keywords that you keep up in your mind is the point Q is 25 mm behind VP. Behind means it should be either second quadrant or third quadrant. If I look up further, the additional point 40 mm below HP, so obviously below HP means it falls under the third quadrant. Now I am marking the point Q. The Q, which is in the third quadrant, is 40 mm below HP. It's marked at 25 mm in front behind the VP, and that point also is marked with respect to the shown pictorial representation. So always it's very clear that the front view we have to mark it as Q dash, and the top view we have to mark it as Q. So the point Q and Q dash has been marked over here. Now with respect to the point Q and Q dash, a tracing line has been drawn with reference to the reference line X and Y. Now you could be able to see the line that I am being drawing connecting the point Q and Q dash. Though it may be looking like a L shape, but as per the pictorial representation, we have to turn 90 degree clockwise. So now the distance between the 2 points given over here is 90 mm. If you look up over here, the distance between the point P and Q should be marked as 90 mm. Locating the point Q is in the third quadrant, and the height is the distance, that is 40 mm. We are just marking over here, and the Q is the distance behind the VP, and that is 25 mm. We have been marked over here. So the same point has been carried. Now in the 2D representation, like orthographic projection, we are going to plot the point P and Q. The P is 15 mm. It is in the first quadrant. That means H by D. So H is 15 and D is something 20 mm. So H always shows the front view and D always shows the top view. The notation for the front view is FV and the top view is TV. Now the point P is marked 15 mm above the reference line and 20 mm below the reference point. The point P dash denotes the front view point and the point P denotes the top view point. That means the point 20 lies in the horizontal plane and the point 15 lies in the vertical plane. Now I am marking the point Q, which is a third quadrant. As stated in the question, the distance between the point P and Q should be 90, and that's what somewhat distance has been kept over here. So similar like this 25 mm has to be marked in the upward direction and the 40 mm has to be marked in the downward direction. The 40 mm is the distance that is located on the front view, that is in the vertical plane, and 25 mm is the distance that marked on the horizontal plane, which has been given the notation Q and Q dash respectively. As per the problem, it's very clearly stated that we have to draw two top view as well as the front view lines. So the front view lines and the top view lines has been connected together, and you can witness the image, and the distance to the 2 point is kept as 90 mm. So this is how we have to draw the projection of points. I hope you people have enjoyed this video. Thank you.